Hello YouTube, how's it going? All tissues can adapt, not only muscles. Today's topic of conversation is around your body's incredible ability to adapt to all of the forces, stresses, and environmental pressure that is placed upon it. But when people think about tissue change, they mostly think about the muscle's ability to adapt and to grow and to get stronger. But rarely do people ever think about the fact that we have data to show that there are tendinous, ligamentous, cartilaginous, and bony major adaptations that are seen in elite athletes. So all of these types of soft tissues have the capacity to actually adapt and grow stronger, become better hydrated, to become thicker, etc., etc. Your body is one big biological, robust bag of meat that is capable of adaptations in ways you may or may not have even thought possible. So let us begin. Again, we all know that muscles can adapt to training. They can get bigger, stronger, faster, longer. I'm a poet and I didn't even know it. Via adaptations such as hypertrophy, neural motor control, sarcomerogenesis, etc., etc. There are numerous different mechanisms to which our muscles can adapt to stimulus. Hypertrophy refers to simply our cells getting bigger, and this is usually where we find growth. But you can also get cell replication, or what we call myogenesis. Strength itself, or muscular strength itself, is very much correlated with muscular hypertrophy, but is also due to different types of adaptations, such as neural adaptations, and it's the same with power and speed. Neural adaptations can occur in a few ways. Your brain or your central nervous system's ability to recruit muscle and nerve fibers can improve, but we also develop typically what we call motor end plates, which is the peripheral point of contact between your nerves and your muscle cells. And these connections can become increased, like I said, but also can become more efficient. Then muscles can also lengthen through stretching or eccentric strengthening through a process called sarcomerogenesis, whereby the sarcomere, which is the basic contractile unit of a muscle fiber, begins to arrange itself to allow for lengthening. At the same time, a lot of improvements in flexibility is also owed to neural adaptation, or the nervous system's ability to become more tolerable to stretch. This is all quite basically how our muscles can adapt in response to external load. But our other tissues like tendons, ligaments, cartilage, and bone also have the ability to adapt. They can get thicker, stronger, and better hydrated. So yes, while all of these other forms of connective tissues or soft tissues are not contractile in nature or do not have a motor function, they can still adapt in response to external load because they are still vascularized and innervated. So here are some examples. Starting with tendons. This paper by Machado et al. In 2002 shows that runners seem to have a larger Achilles tendon cross-sectional area and a higher Achilles tendon stiffness compared to non-runners, suggesting a tendon adaptation to accommodate this higher mechanical demand. So tendons are still contractile to some extent, and they also very much function because of their elasticity. In the case of a runner where you need the tendon to function like a spring and propel your body forward for thousands and thousands of strides per day, an adaptation like increased stiffness is a positive change and allows for a higher force production of the Achilles and thereby better performance. The larger cross-sectional area also means that it has become thicker. For ligaments, these two studies found significant hypertrophy in the ACL, or the anterior cruciate ligament of the knee, in elite level weightlifters and jumping athletes. Jumping, plyometric exercises, and shearing movements may expose your ACL to some extreme forces, but this doesn't always necessarily mean that it is a bad thing. Yet again, we seem to see that they thicken in response over long-term exposure. There was another recent-ish study that I didn't include in this post that showed that hockey players' ACL had increased in size post-season as compared to pre-season. So from only one entire sports season, their ACL in the knee, in both knees, had increased in size quite significantly. But the authors concluded that these weren't necessarily positive adaptations, or maybe they weren't even adaptations at all. They thought that they could be due to micro tears and subsequent swelling as to why the ACL had, increased in size. So just from, increased fluid and tissue damage. But we can't know for sure. I wanted to include that little note because, we don't always have positive adaptation to extreme forces over long-term durations. But nevertheless, let's move on. For cartilage, I've selected examples of intervertebral disc or spinal disc adaptations, as it is a fibrocartilaginous structure. Belave et al. In 2016 stated that repetitive dynamic axial loading exercises result in positive intervertebral disc adaptation in their literature review. Frenken et al. In 2022 conducted a study looking at elite level rowers. Their discs were found to have increased disc glycosaminoglycan content, so improved hydration and nutrition. And then in the same light, this 2007 paper by Belave et al. Yet again analyzed runners who were found to have increased disc height and hydration or proteoglycan content. Let's just move on to bone. This 2014 paper by Warden et al. Looked at MLB players, Major League Baseball, who showed significantly greater total and cortical bone areas and cortical thickness in their throwing arm compared to the non-throwing arm. So not only were their bones thicker from an outside perspective, but if you did a cross-section of the bone and looked at the cortical area within the bone itself, it had become significantly more dense in the throwing arm only. So we see how receptors don't only respond to weight-bearing exercises, but external forceful movements in general. In conclusion, as you can see, our bodies can become quite resilient and adapt in response to the specific stresses that are placed upon them. It painstakingly kills me to see other physios, healthcare providers, personal trainers, and fitness influencers demonize normal human movements and postures and categorize them for being right or wrong as if we know the difference. The whole point of this post is to reinforce an optimistic narrative surrounding the body and movement and exercise. There are, however, some cases, like I said, where extreme stresses in sporting environments may cause negative adaptations to our tissues. But the idea that specific exercises or activities cause harm, stress, or wear and tear to our joints is simply a myth that refuses to die. In whichever way you want to move, your body will adapt. That's all, folks. Thank you for watching. Please let me know if you enjoyed this type of video. Let me know if you have any questions, concerns, comments, recommendations, and I will see you in the next one. Peace.